Good morning, Year 10s. As you can see, I'm not with you today. Instead, you have relief teacher because I'm on a course. Now, so we don't fall behind, I'm going to push ahead with the content, and today we are going to look at gradient much more closely. So, as we're going through, feel free to put up your hand and ask the relief teacher to pause the recording so you can catch up on notes, because I realise when I'm talking to myself, I tend to go more quickly than I would with a class. Can we get started, please, by taking out your notebooks and writing gradient/slope at the top, and then drawing a Cartesian plane underneath like I have. Now, you'll notice the Cartesian plane has some important points. You need to label the x and y axis, you need to put a scale on there, and you need to put arrows. Essentially, if you're asked to draw a graph in a test, each time you miss one of these things, you'll lose half marks. Which doesn't sound like a lot, but over the period of an entire test, it starts to add up. Now, slope is a concept you'll have come across before, but if we were going to ask for the slope between these 2 points, we'd like to think of a couple of different ways to calculate it. Firstly, I like to think of that as a staircase, and as a little person is moving from left to right, they're going up the staircase, so we know that our slope will be positive. So think positive up. If the staircase was heading down, so from here to here, then our slope will be negative. Now, our slope equation, slope, which we call m, is the rise over the run. It's essentially how much that little man climbs divided by the amount he goes across. So, in our case, at the top here, he climbs 2 squares from his starting line here, meaning his rise is 2, and the run is 1, 2, 3, 4. 4 over 2, which simplifies to a half. So the slope between these 2 points, the slope of that line there, is a half. Right? So, take a little man on our second line. His slope is going to equal to his rise, but he's not rising anywhere. Instead, his change in the y will be going down 2. 1, 2. So it'll be minus 2. And his run will be 1, 2, 3, 4. So it becomes minus 2 over 4, giving him a slope of negative a half. Now, we don't always want to have to draw a little Cartesian plane, 2 points, and a little man every time we go through these. So, instead we can use a formula to work these out. And for the formula, I'm going to put 2 more points on my rather crowded Cartesian plane. My point is going to be here and here. Now, yes, we could count across and we could count up if we wanted to. But, instead, we can consider this our first point. And our first point has coordinates of minus 4 and 1. And our second point has coordinates of 4 and 3. And our slope formula for m is equal to y2 take y1 over x2 take x1. Now that looks scary, but if our first point here is minus 4, 1, then minus 4 is our x1, and 1 is our y1. And the second point is x2 and y2. Alright, so we've simply labelled the points with their coordinates x1, y1, and x2, y2. And then we use this equation for the slope. So y2 in our case is 3 minus y1, which is 1, divided by x2, which is 4, minus x1, which is negative 4. And it's important to keep that sign. 3 take 1 is 2. 4 minus negative 4 is going to be plus 4, so that's 8, giving that line there a slope of positive 1/4. Alright. Now let's just use this formula here on one of the lines we used beforehand, just to double check it works. So let's consider this line here. Its first point rather, is going to be minus 1, and its last point here will be positive 3, negative 3. Alright, so if we label these points x1, y1, x2, y2, we can use our formula. M equals y2. We go search for it, it's minus 3. Take y1, take minus 1. There. Divided by x2, take x1. Note the double negative again. Minus 3 minus minus 1 is the same as saying minus 3 plus 1. Minus 3 plus 1 is minus 2. Divided by 3 plus 1, 4, equals minus 1 over 2. So whether you imagine the slope as a little man walking up and down an escalator from left to right, or simply using the equation, the formula, you still get the same answer. So slope you can either think of as rise divided by the run, how much a man goes up and down, divided by how much he's running across, or m is equal to y2 take y1 over x2 take x1. Both get you the same method. However, this one here, that equation formula, doesn't require you to draw a picture and count. Now, our equation of a line. In general, a general equation of a line is y equals mx plus c, where this m is what we've just been looking at. It is the slope, and that c is the y-intercept. And this is the equation of the line that we'll be looking for much more regularly. Right. Now, the equation of a horizontal line is a little bit of a strange one. Essentially, if we go and look at a graph, which we'll look at later, and have a horizontal line on it, then every point along this line is going to equal the same y value. It is at the same height. So if this here was 3, the equation of this line would be y is equal to 3. So a horizontal line equation is simply y is equal to any constant, a, but x isn't involved at all. That returns a horizontal line. Now if you want a vertical line, every point on this vertical line is going to be equal to the same x value. So for example, if that there was minus 2, then the equation for this line here will be x is equal to minus 3. So our equation of a vertical line, is going to be x is equal to just any constant, b. And notice how y isn't involved at all. So when you see an equation With no x, it's horizontal. With no y, it's vertical. When there's both an x and a y, then you'll have a line like we had above. And today we're looking at how to discover the equation of a line, of any line. And on the note of practicing this lesson, I would like you to focus the remainder of this double and tonight's homework on those questions. Page 171, questions 1 to 10, and go through the green sections. Alright? Yes, I know it's a lot of questions, but practice on this will pay off when it comes time for the tests and exams.